And our next speaker is Joseph Wright from the LaTeX team, and he will talk about supporting backends in expl3.
Right, thank you. So I'm going to talk, as it says, about this is my expl3 talk, but some of you will be pleased to hear there's no underscores or colons anywhere on any of the slides. So it's going to be about sort of ideas and what we've been trying to do. So we start off with the question about what does TEC not do? So we all know that TEC does very high quality typesetting, but when Knuth designed it, he left some things deliberately and some things because they didn't exist out of the list of things that TEC does. So color is the first one. What does TEC do when it places things? It is saying there is going to be some ink on a page, effectively, some colorant, but it doesn't say what color it is. That's left to other people to decide. So obviously if you want to do color, you need to be putting in additional instructions. It doesn't do image inclusion. TEC doesn't, I mean, classically, always telling people, when you get to something like include graphics, it doesn't really matter. It's just a big letter as far as TEC is concerned, or just a big box if we want to be even more precise. So the actual, how does that image get into the output? TEC doesn't give us stuff about that. Doesn't do hyperlinks. Hyperlinks didn't exist, and certainly don't exist in a physical book if you think about it, but they certainly do in an online version. But again, TEC doesn't need to know about that. PDF constructs, I mean, I'm thinking things like creating color spaces, creating masks, soft masks and things. Certainly if you're making PDFs, obviously only PDF specific, but again, definitely not something TEC knows about. And obviously tagging, an important topic as we've just heard, and TEC doesn't know anything about that, and again, something which postdates TEC being written, but that doesn't matter. Because, as I say, there were things that certainly were there from the word go that TEC didn't do, but Knuth had given us a mechanism to handle that. So if we look at a sort of, I'm going to say the classical approach, how Knuth would do it essentially. If we take a plain TEC document and we want to put in some color, what do we do? Well, if we're a plain user, we're obviously going to write this for exactly the output format we want. So we're going to know all of this stuff, and we're going to hopefully, for a plain TEC user, we're also going to know the code we do need to create the colors or tagging or whatever, and we're going to do it all manually. And what's that mechanism? That mechanism is the primitive special. And the primitive special is Knuth's solution to this TEC can't possibly do everything problem. You have a single command that takes balanced text, some arbitrary information, which it doesn't know anything about. And it is just going to put that into the output. And here, as I'm thinking about a classical plain situation, that's a DVI file. And it's going to put that, and it's going to say, right, the next thing that looks at this DVI file can do something with this. I don't know what it is. And so then that means, of course, that whatever we put in that argument is going to have to be written for what we know we are going to do next with our DVI file. So what that is going to mean is, and the reason it's called special is that the nature of that text that goes there, that information, is going to be completely dependent on what our tool chain is. And as I say, if you're a plain user, that's fine because you're in control of everything and you know exactly what you're doing, and you can adapt it. You know, if you switch your tool chain, you'll go back and just edit this because you'll be knowing what you're up to. But in the LaTeX world, we found that most users asking them to understand the syntax of specials would be completely insane, because asking them to understand the syntax of LaTeX, which is written in a very nice book that Ulrika's just held up, and it's like people don't seem to get that at all. So the idea that, or telling them you've got to change part of your source because you've changed from making a PDF with PDF tech to a PDF with ZTech, I think would be not a good sales pitch. That has been a problem, or something that the LaTeX team has thought about for a long time, and so we go back to certainly the early days of LaTeX 2e. I'm not sure exactly when David wrote this, probably early 90s. We have this file here, drivers.dtx, and I've taken just a little bit of drivers.dtx, and essentially I'm going to come round full circle to this idea, but there's some subtle differences. So how does this work? The idea is that we have a number of different, what I'm going to call backends, things that take classically the DVI output, or now built into the engine, and we get direct PDF creation in PDF Tech and LuaTech, and they're going to do something with it. And each of them is going to have its own syntax, but they're going to have commonality. If we want to set a color at a high level, we want it to be green, or we want it to be red was my example, and the user, in a LaTeX sense, doesn't care what is going to happen. Red is red. So they're going to put color red, and then stuff is going to happen, and we're going to get to a point where we can't anymore ignore what backend we're using. And that's where these files are going to come in. They're going to define the bit of the process that is backend dependent. And if we look back to, say, the early days of LaTeX 2E, that's a long list, and this is not the full list of provide files in drivers.tcx. It's as many as would fit on the screen, missing out the first one because I wanted the first one on my list to be DVIPS for reasons we'll see in a second. So if we look at that list, what we'll notice is there's only one of those backends that's still in use, and it is indeed DVIPS. The rest have all disappeared into the into history. And so this looks like a good plan in many ways. So why am I having to talk about this, say, coming full circle? Well, what happened is, so that file got written, and then obviously life happened, but things are being developed, particularly PDF Tech initially. So new engines, PDF Tech, ZTech, LuaTech, PTech and UpTech as well, and so they may impact a new backend. So we've saw on there we had DVIPS, which we're all familiar with. We had DVI-PDF, I think was the one that was on the list, which obviously now we might see as a sort of successor is DVI-PDF-MX, but it's certainly not the same, and it's got different things going on. And there were ones that were not really thought about at all back in the early 90s. So new backends which need new support, but essentially drivers.tcx was frozen many years ago because at the time the team didn't have the resources to address that, but also contributing was tricky, and because people wanted sort of, there were lots of people working on different platforms initially, and it wasn't easy to, great, wasn't easy to deal with trying to keep up with all of that for the team. So what happened? People looked at dvips.def, and so it's sort of, in many ways, the standard def file, because, as I say, that's the backend that has stayed around, and it provided a lot of useful features early on. And so people took that file and then added features to it, or added support, edited it to bring in new backend support. And if we talk about new features, a lot of those were added as the PDF Tech engine was developed. Lots of stuff got added there. In particular, if you look at PDF Tech, so we've just seen Knut's solution was this one primitive special, which doesn't know anything about what's going on in the contents of that argument. But PDF Tech, although you can do some stuff with special, that's not the best way of doing it. And the reason for that is that particularly when you get to things like hyperlinks, you want to know that the engine needs to track things like where the outside of the link is because of the way that hyperlinks have to be made. And that means that you can't just have a black box. PDF Tech engine actually tracks stuff about these various primitives so that they work together. So there is a need to do things slightly differently. There's also features added there. So historically, or until we sort of came back into this area, the PDF Tech .def file was adding new keys to graphics to support features which DVIPS doesn't understand, like multi-page image inclusion. And so that you end up with a sort of divergence of support. So then I sort of came into here to look at, with the plans, the team to try and provide a consistent programmers level interface for all of the primitives that you might want to use. And that means looking back at how you provide those interfaces to the backend file systems in order to re-abstract them into that sort of model. And so I looked at this and I thought, well, the drivers.dtx plan was a good one. You've got, if you look at making lots of separate def files, we heard yesterday about reusing code and not writing things more than once, and you end up doing exactly that for backends which share similarities. Most obviously, PDF Tech and Lua Tech share a lot of similarities in how they approach things, as they both make PDFs directly. There's also quite a lot of overlap there with ZTech because it can do some of that. And so you really don't want to be having all that written out separately. So I went back to the idea of having a single source. The other idea was, if you look at the early 90s files, they cover color and graphics because they were the things that were known to be covered at the time, and then they got frozen and other stuff didn't get added. So how did people add other back-end specific features like hyperlink support or drawing support or tagging? It's all done by having lots of separate little files for each package having to do its own back-end test and then define its own interfaces. And sometimes there's repeats there because it turns out you actually want the same ideas in different areas. So the idea was to go back and say, right, no, we want to sort of cover all of the, or as much as we possibly can of the back ends, and over time to extend rather than to start with a fixed list. There's also an advantage here, far fewer back ends to support. So the days of having different people having different platforms or different commercial tech implementations with their own backends that had to be handled separately are in the past. So we have essentially a fixed list that we support. There is a little bit of variability when you start thinking about people obviously doing their own engine development, but if you look at end users, they're going to be using backends that are available in TechLive or MikTech essentially, and we can predict that list. So that makes life a lot easier. It also means we can test them because we can run all of that on our automated testing system. Documenting decisions. Yeah, so writing back-end code is interesting because you read the documentation for a lot of backends is quite sparse, and there's a lot of information that's been collected up about what actually works in various def files with limited comments in them. So particularly ZTech is probably the worst offender, and the reason it is ZTech uses the XDVI PDFMX backend, and it always does. That was originally a separate program derived from DVI PDFMX. Now it's brought back together, but that fact that it was derived and then someone else was writing it meant that it got some support added that was separate from DVI PDFMX, and they then inherit some stuff from DVI PDFM, and then that inherits some stuff from DVI PS, and it's also got some direct PDF production potential as well. And so there's sometimes 4 or 5 ways of doing the same thing, but you need to test them out and work out which one, when you put them together, still produces the result you'd expect. And that means when I say produces the result, it means you actually have to look at the output and check it looks right. So think particularly when you start combining rotation and hyperlinks, that's a place that things can get very hairy. And also, because of this idea of wanting to have a single source and have things brought together, there's also the idea, if you can do stuff the same as PDF Tech, which is now kind of the reference backend, then I'd favored that over some other method. So, but you want to document all of that. Why did Joseph pick this one and not something else? So that's all the idea that we can actually document it. There's now a clearer route for addition. So, yeah, if you go back, if you'd wanted to make a contribution to drivers.dtx 30 years ago, you'd have had to email the team list, and then that had to go into some baroque system via various people to get it into the sources, and then you'd have to wait for it to be distributed, whatever. So now it's a lot easier if people do want to suggest additions. The sources are on GitHub. Obviously, other hosted solutions for distributed version control systems are available. Don't want to be tied to any one particular system, but the point is there are lots of those. It's a lot easier for people to see and contribute to the code. So if there are new backends to be developed, that can be done. It doesn't have to be done by the LaTeX team. Obviously, there's a limited number of people who know expl3 and the backend detail, but Actually, most people, I think people developing any new backends would probably look at one of the existing ones and hopefully stick close to what it does, because going completely off-piste is probably not a great plan. So that takes us to sort of the question of what's supported. So at the moment, if you look at the list that you can load, it's quite short. So there's PDF and Tech and LuaTech for making direct PDF output. DVIPS is still there. There is some fun there. You get into, you're abstracting stuff out, and you can't abstract, it drives to some extent what you decide to do. The moment you want to support PostScript, you have to deal with the fact that PostScript, when you do color, doesn't have the concept of stroke and non-stroke color, whereas PDFs do, and PDF Tech and LuaTech have multiple color stacks that can be used to track that, and DVIPS doesn't, so this sort of thing. So the list of backends you support drives where you have to put your abstraction. So particularly, I've also got DVI SVGM there, and so that's not making PDFs, obviously, it's making SVGs, and it turns out there's quite a lot of features that all of the other backends share, apart from DVI SVGM, so that means that rather than have it, so it means that ideally, the backend files would have, only the code that's different, but because you want to support that, you have to, where the difference is, moves around. So here we have DVI PDFMX, and although it's nowadays the same program, there's one or two subtle differences in the way ZTech can do stuff compared to PDF Tech running in DVI mode, and so you have to have a separate backend file there. And then we can think about the features that we want to include. So you've got color, which I think is one that, we've been around for a long time. Image inclusion, again, quite straightforward. It's got a little bit more straightforward maybe over the years. Box transformations. So the original design of the graphics package was driven again by what the backends at the time could do. And at the time it made sense that you would try to leave image, scaling, rotation, whatever, to the backend, and you wouldn't try to scale, you couldn't necessarily scale, rotate, whatever other content. I've looked for expl3 gone slightly differently. In the image inclusion, it's just image at natural size as it is. And then if you want to do rotation, scaling, whatever, that can be applied to arbitrary content, so those two are separated out. So, so box transformations, clipping, rotation, scaling, skewing are all separated out. Drawing, so obviously we've got Henry here who looking after PGF. So drawing there, I said lots of PGF type stuff, putting graphical type commands, draw a line, draw a circle, whatever. Now, obviously, not about to compete with PGF because there's the TIX layer, particularly on top of that, does a massive amount of stuff. But at the same time, one of the design aims for expl3 is having documented progress interfaces to all of these possible functions. So there is so that means you need back-end support for all of those things, and that code is heavily modeled on the one from PGF, other than one or two places where I slightly rejig things. Hyperlinks, again, as I said, hyperlinks are interesting because when they start, because of the way hyperlinks actually work, you have to worry about their interaction with any changes to the canvas of when you're making a PDF. Then we've got tagging. Now, currently, tagging is partly in the core drivers and back-end files, and partly in some that is in the test phase because that's still got testing going on. But Ulrika and I know that will be, say, that aim of having it all in one place. As we firm up, finalize decisions about tagging, those tagging parts of the code, the back-end code will move into the same core files as everything else, so you won't be loading multiple files. Be one set of files to load. And then PDF structure, so that's again more complicated. What do I mean by PDF structure? That's stuff, it supports things like color spaces, like the tagging to some extent, and that's things that have to appear once and have to be managed globally, and they are interesting to deal with. And again, that's one that's currently not in the main files because there's still have to work out exactly how we coordinate management of that with things, any other packages which also want to manage these unique structures for PDF creation. But that is what we're doing. The idea is it's in many ways a sort of history going round in circles, that we've come back to the same idea that we had a long time ago. But I think if you look at the work we've done on this over the past 10 years probably, we've shown that we can get all of this stuff in, and now that it's much more responsive to changes and to get improvements, I think that that is a good thing. And hopefully, the other thing I didn't say on the slide is there's also testing on this, which is important. Obviously, we can't test the output. You can't test what the output actually looks like. You have to look at it, but you can test that you don't at least mess up the structures that you've created. So if the structures stay the same, then you're confident that, other than viewer fixes or whatever, that it will still look right, or at least you know when you've changed it, which is, again, very important. So the test suite we have runs the tests for all of those different backends to make sure that we are getting what we think we're getting. So that is what is happening with backend support in expl3. Thank you very much, everyone.
Thank you, Joseph. Please, before it's too late, ensure that your phones are silenced. Okay. Sorry, Joseph.
That's okay.
Any questions?
I somehow had an impression that you had backend for hint format, but I don't see it in the list.
So no, we don't. So we've looked at, so hint is currently not in Tech Live for a start, so testing it would be very difficult. Or it is, but it's not. It's, the version that's in Tech Live is, because of the way Tech Live works, is a long way behind the development version, so I'd be reluctant to add it into the release code. There are some complicated questions there, particularly about image inclusion, because of the way hint works, images don't have size, and then doing image inclusion is interesting, because a lot of, back with the idea that your level of abstraction is driven by what the common position is, and it means that the common position doesn't work, and then it's not clear to me exactly how to handle all of that. So at the moment, I'd say hint is probably still too much of a moving target to really consider adding to the distribution set. So it's a question of we can talk about things and work out how we might do it, but it's not really at the point where it would be sensible to include.
Any other question? Of course.
I have a question as an engine developer. Wouldn't it be easier if the LaTeX team would say, okay, we have a specification like for image inclusion of a set of primitives, and whoever wants to use LaTeX with images has to conform and just provide that set of primitives.
Well, as I say,
and that would push the responsibility away from maintaining drivers to those who develop engines.
Well, it's...
I think it would also be better for the engine developers if we would have a clear specification. This is what you need to provide, and period.
That's tricky, because if you look at that list of supported backends, only 2 of them use primitives in the first place. The rest is all just special and whatever's inside special, and a lot of that's history. I see what you're getting at. In the end, I mean, so in the end, we can define a backend that simply has lots of no-ops where things aren't covered, and to some extent that's what happens with DVI SVG, because a lot of it just doesn't apply. We haven't. So the reality is that for the past 15 years, 20 years, probably nearly, that list of engines, other than LuaTeX development, which was originally just PDF tech anyway, and then the split was quite clear because the syntax of the names changed, but the way they worked essentially didn't. We haven't really had to deal with people coming up with new engines that need a spec. I, 'cause, I, 'cause, 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 I mean, I suppose we've tried to be as flexible as possible. I say the specific issue for hint is the image inclusion. As fundamentally, whether you could come up with a spec that would work doesn't make sense, because if you're going to say the images don't have a natural size that you can query, then that's quite difficult to see how you deal with that.
I think we can
Yeah.
deal with the hint problems on it.
Yeah, yeah. I mean,
It's included since TechLife 22,
yeah.
so it's already there. And images that don't specify a size might not have one in it. So that's right.
Yeah. I guess this has been mentioned whether we should have a standard set of requirements. It's certainly doable. I mean, it will just be a question of me going through and working out exactly where the abstraction level sits for everything and what information is absolute. It's probably not primitives, it's a question of what information do we have to be able to access in some way. I see what you're getting at, yeah.
Any other question?